Hi everyone, Crystal here from Leetcode Mate. In today's videos, I'm going to walk you through how I solve merge to sorted list problems from Leetcode. I also share some important tips and tricks to help you ace your coding interview. So breaking down the problem in clear steps is essential, and these videos will guide you through how to approach it. Let's jump right in. The first step we need to do is let's read and understand the problem statement. You are given the head of the two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. This list should be made by sliding together the node from the first two lists. Return the head of the merged linked list. Before solving any problems, it is crucial to clarify the requirements. So for these problems, I would ask a few clarifying questions. For example, are these two input lists already sorted? And we know that right from the beginning, it's already sorted. And then, should the merged list also be sorted in the ascending order? It's already in the ascending orders from the example that they give us. Then the third questions we can have is, how should we handle the empty list? So for example, list 1 here is empty and list 2 here is empty. And I see the example 2 here. Let's have list 1 and 2 is empty, so the output is also empty as well. And in example 3, let's have list 1 is empty and list 2 only have one number. So the input here is also have the numbers in list 2. So here we have the clear understandings about this detail and then the key to prevent the mistakes during the coding. The next part we need to do is identify the input and output. So let's see. So the input here is pretty simple. It's a linked list, list 1 and list 2. And then the output is the head of the linked list. So the next step we need to do is matching the problems with the data structures and common patterns that we already learned. Let's think about the common patterns and data structure that we can apply for this one. Since we are working with linked lists, and we need to merge two sorted linked lists. The key pattern in here is using two-parter traversal. Whenever you see the linked list here, it may signal you with a technique on two-parter. So since we know that we can using technique called two-parter, so let's see how we can blend it out. So here I will using the first example. So list 1 we have 1, 2, 4, and then list 2 is 1, 3, 4. And then in here, since we know that we need to use two-parter, the first parters will be at the index 0 of both the list, list 1 and list 2. So we have part 1 is part to node 1 here, and part 2 is also part to node 1 of list 2. So once we have these two-parter here, we can put it inside a while loop. So we will continue looping until one of these two-parter is our bounds, is at the end of list 1 or at the end of list 2. So right now it is not our bound yet, so we can directly compare together. So here we have part 1 is part to node 1 and then part 2 is part to node 2. So this one is kind of like equal to each other. Since it's equal, then you can adding either the part 1 or part 2 into the merged list. We will have the current is our head. Another technique in here we were using other than two-parters is using dummy head. So the dummy head will be so helpful for these problems, and it's especially for linked lists. So you will have the dummy node for the new list. So this one will be a node. Can do is node -1 is dummy head, so it's just there. And then the current is actually will add it into the merged list here. So we will assign it to be the dummy. And then in here, once it is equal, then we know that we have to put it inside the current. So right now the current we have is 1. So we are pushing the number in list 1, make it easier. So this is your dummy here. So dummy node is -1 here. Since current equal to dummy, so it's part to the same -1. And then we want to add 1 here. So we know that 1 should be going to here. So, and then we will move current to here. to the number 1 that we currently have. We already finished with number 1, so we need to move P1 into the next node. So in here, we're moving it here. So right now, as it's pointing to number 2, so we compare the value of these two nodes. So we know that the numbers in pointer 2 is smaller than the value in pointer 1. So in here, we will adding the value 1 here inside this array, inside this linked list. So 1 here as well, and then moving the current as well. So the current will move to here. Okay, and then we finish with pointer 2, so we will need to move it here. We have pointer 2 is pointer to node 3, and then pointer 1 pointer to node 2. So we compare the value for these two pointers. So we know that pointer 1 value is lower than pointer 2 value. So we will add number 2 here inside this merged list as well. So we will have, and then after we're adding it, we will move the current as well. Continue like that. We will moving the pointer 1 to the next node. So in here, we compare pointer 1 with pointer 2, the value of these two pointers with each other. So 3 is smaller than 4, so we know that we have to put 3 in here. So 3, and then moving the current and moving the pointer 2 as well. So right now we have 4 and 4, which is kind of like the same, so we can just continue adding the pointer 1. So here we will adding 4 here and then moving the current as well. And then after we adding 4 into the merge list, this pointer 1 will update, and then it will be pointer null. So see, this is at the end of list 1. And pointer 2 is still at the node 4 here. When one of the pointers is null, then we can push whatever the pointers have some value into the merge list. So in here, we still have pointer 2, pointer 4. So we know that we can just put 4 in the end. So right now we kind of like finished with the merged list here, but just need to return the head of the merged linked list. In here we have the current is pointer to node 4, and then the dummy is pointer to -1. We cannot use the current anymore because it's way far from the head. So that is why we have the dummy head here. So this dummy head here, as we'll do is once you have, so this dummy dot next here will be the head of the merged linked list. So dot next, so that means it will start from here. So this one here, node 1 here, would be the head of the merged linked list that we already have. So that is how the algorithm works. So let's see how this algorithm will be coded. So like we had before, let's declare the dummy head first. So list node dummy head, actually just call it dummy, and then new list node. We can put it -1 for the value since we also not use it. We also need to create a node current. This one would be equal to the dummy. So as we'll continue running inside this merge linked list. So now we have dummy and then the current. Now we need to have the pointer 1 and then the pointer 2. So we can have list node pointer 1 as we'll point to list 1, the head of list 1 node, and then the pointer 2 will be part to list the heads of list 2 here. This is how you identify the pointer 1 and pointer 2 in linked list. It's not using the index, it's using list node. So that is how you declare it. So in here, we know that we have pointer 1 and pointer 2. We can do a while loop to make sure nothing is out of bounds. And pointer 2 is not null as well. Then in here, we can continue running our algorithm. We will check the numbers, the value in part 1, whether it is smaller or equal to the part 2 dot value. Remember this step, we have part 1 is 1 and part 2 is 1 as well. So this one is equal. So in here, what we did is putting list 1, the node in part 1 into the merged list, right? So that means we will have current.next equal to the part 1. And then we will move the pointer 1 to the next node. So .next here. And then else we know that we will need to put part 2 instead of part 1. So the same current.next equal part 2, and then part 2 will get updated. So part 2 dot next. So after this, we also need to update the current. So the current also need to move to the next node. So current dot next. Okay. So now we at the end of this while loop, we have the merged list until here. Remember, when the part 1 is null, then but it still have part 2. It's part 2 number 4 here. So in here, we need to have a check. So if part 1 is not null, then we will add it to the end of the current. So current would be equal to the part 2. And then the same things will be for the part 2. So once you have current next, going to be equal to part 2. So after you have this if, you can just do return the dummy.next, which I already explained in here, as we'll have the head of the merged list that we already prepared here. So yeah, this is the end of the coding section here. The next step we have to do is testing it out. In the interview settings, some company will have the IDEs for you to run tests, but some of it doesn't have the IDE for you to run. So you can run by hand, you can just do one by one, like move the pointers like I just did in the planning step. But right now we in the Leetcode, we can just using the IDE as do to reduce the time here. So let's run it, make sure everything correct. So all 3 cases is correct now. So let's try to submit it to see we pass on the each case. So we have the accepted solution. So the next step in here we have to do is to analyze time and space complexities. For time complexities, we will have, since we have 2 pointers, we have list 2 and list 1. And these 2 lists is not the same size. So we need to identify the length of it. Since we have to go through the whole linked list, we cannot omit any node inside these 2 lists. So the time complexities of it will be big of n plus m, with n is the length of list 1 and m is the length of list 2. And then for the space complexity, as we can see in here, we have dummy node, current node, pointer node, but all of this is just a node, and this doesn't store anything other than just the node. This means the space complexity of this one is big O of 1. So to recap, the time complexity of it is big O of n plus m, and then the space is big O of 1. That is how you solve the merge to sorted list problems efficiently. By following this structured step, understanding the problems, planning your solutions, analyze the time and space complexity, you will feel more confident in your approach during the coding interview. And then for more personalized problems recommendations and coding strategies, check out LeetCodeMate's website at the links in the description below. In here, we just did the problem, so I will add the problem right in here. And then I think we just do it in 30 minutes. So I just do O1 here, and then stop. We have time start and time end to make the recommendations personal for you, and then you will practice like in the interview setting. And then for the category, we know that we are dealing with the linked list, so we're choosing the list as a category. And then in here is already preview for you. For the difficulties, you can do is analyze whether this problem is difficult for you or is easy for you. So in here, I think it's easy for me, so I just put 1 here. For a tip for yourself, you can do is like 2-pointer approach and then dummy head. So once you come back to these problems, you will kind of like remember the techniques that you use. So right now, I can just submit it by adding the problems. So continue. And then once you're adding the problem, you can see in here, there's a category list added. It's in here, it will tell you how many days left until your next practice for this category. Until that time comes, you can come back here. And then it will show you the recommended problems for you to solve. So in here is this reverse linked list. And this also have the difficulty is easy and frequency is 70%. And then you can view the problem here or start working right away. And then it will preview most of the steps here. You only need to enter time start and time end, and then that's it. Okay, right now I just cancel it. Okay, and then down in here, you can see it. Merge to sorted list is added to your tracker. And then in here, you can see it set the times practice for each category, and then the difficulties of it based on what you're rating. If you find this video helpful, don't forget to like, subscribe, and hit the bell for more interview prep tips. Thank you for watching, and I wish you the best in your coding interview.